the derivation of second order differential equation. Like in my previous class, I derived first order, the f over the t. So this time around, I'm going to derive second order, d squared f over dt squared. So now Laplace transform. I have Laplace transform. Laplace transform. So to find the Laplace transform of d squared f over dt squared. It's a find the Laplace transform of d squared f by dt squared. Now, this you take f of t equal to d squared f over dt squared. This means a second order differential equation. So now, for you to derive this second order, for you to obtain the Laplace transform of second order differential equation, you will make use of Laplace equation, which is f of x is equal to the integral sign from 0 to infinity. You have exponential raised to the power of minus st multiplied by f of t times your dt. So this is the formula. So now, from here now, I'm going to substitute the value here, f of t, in this equation. In this equation now, you see I have f of t here. So now, my f of t now is d squared f over dt squared. So I will do it in this form. I will substitute it. Then you have it this way. F of x equal to exponential. F of x is equal to integral sign from 0 to infinity. Then I have my exponential raised to the power of minus st. Then my f of t now is your d squared f over dt squared. You have your d squared f over dt squared times your dt times your dt. Times your dt. So what I'm going to do now is that if you look at this equation, I have two functions. The first one is this exponential raised to the power of minus st. Then the second function is d squared f over dt squared times dt. So now, let me take my v equal to exponential raised to the power of minus st. Now, if I take my v equal to this, then I will differentiate v with respect to t. I have the v over the t will give you, then you have this minus x multiplied by this exponential, that's e, then raised to the power of minus st. So now if you look at this now, you see that your constant is minus x. So the constant now, minus x will multiply this exponential, which is e. Then with the same exponential will carry the same power. That is power minus st. So now, if you bring this to t here, you're going to have a value for dv. Your dv now will give you minus s exponential minus st times what? dt. So now I have gotten the value of dv now in a differential form. Mind you, this first now, if you look at this equation now, Here now, I take my v equal to exponential raised to power minus st. So this one now, the v is not in the differential form. So I differentiated it to get the differential form, which is the v equal to this. So now, meaning that my dv, that my dv now will give you minus x exponential minus st times the t. So now, since my v is equal to this now, so now let me take my du. Let me take my du equal to d squared f over dt squared. So times dt. So this one now is my du. Why? Because the first one, I take my v equal to this. It's not in a differential form. So meaning that I will now take my du now. My u now will be in the differential form, which is du equal to d squared f over dt squared times dt. I will show you why the value my du is equal to this. So now let's see. I want to split this second order differential equation. And my second order now is d squared f over dt squared. So I have that my d squared f over dt squared will give you is the same thing as d over dt then multiplied by df over what? Dt. So my d squared f over dt squared is equal to d over dt multiplied by df over dt. So why? If you have d times d, will give you d squared f. You have d squared f. Then this dt times dt will give you dt squared. So it will give you this. So now you see that you can split now. Since my d squared f by dt squared will give you this, will give you this. So let me substitute here, this one to this point to here. Then I can now have my du. My du now will give you d over dt, then multiply by df over dt. Then I have my du equal to d squared f over dt squared. And my d squared f over dt squared will give you this. So I've already written it now. Times this dt times my dt. You understand? So now I will now do what? This dt will cancel this dt. So I will have du is equal to d multiplied by df over dt. You understand? So now, where I'm aiming at now, why I'm doing all this thing, why I'm doing all this thing is for me to get a value for u. I want to get my u. So you see now, how do I get my u now? You see that looking at this here from your left hand side, and then looking at this equation from your right hand side, you see that I have d here, I have d here, meaning that my d is common. Since d is common, they will cancel each other. So they will cancel each other. So I'll have my u now. My u now will give you df over dt. So I've gotten a value for u now as df over dt. Now, in order to obtain the Laplace transform of the second order, I will make use of integration by parts. So the integration by parts is u v minus integral of u dv. This is integration by parts. So I wouldn't want to show you how to get this formula. This formula, you can get this formula, this integration by parts, through product rule. Now, from here now, I have my u here. The first one is u, then multiply u by v. What is the value of my u here? I've gotten it now. I've obtained my u here from du, which is df over dt. So I will put it here. So I will have it here equal to df over the what? T. Then what's the value of my u now? What's the value of my v? My v now is here. I have my v equal to exponential raised to the power of minus st. So I will put it here, which is times exponential raised to the power of what? Minus st. Now I have it. Then minus integral. This is integral. Integral now, this integral is integration sign. I have my integral. Then I have my u still as the f over dt. Then multiply by dv. Now you see that I have gotten my dv. I got my dv from v here. I differentiated v with respect to t. Then I got my v, dv equal to this. So this is the value of my dv, which is minus s exponential raised to the power of minus st times dt. So I will put it here. I will put it, which means u is multiplying the dv, and this is u, and my u is equal to the f by dt. So I multiply by dv, which is minus s multiplied by exponential raised to the power of st times what? Dt. So now I will bring it this way. I will bring this equation back, so it will now be clear. This equation, I'm going to bring it here. I have the f over the t. By the f over the t is this u. Then this v is my exponential, which is e raised to the power of minus st. Then I have this minus the integral sign, that's the integration sign. Then I have u. My u is still the f over the t. Then multiply by the v. By the v is this minus x exponential raised to the power of minus st times t. So I put it here. Minus s multiplied by exponential raised to the power of minus st times dt. So the equation now will take this form now. So now I've gotten the equation in this form. So what I'm going to do now is that this exponential now is carrying a negative power. So in order to convert it to positive power, I will apply law of indices. I will now take the inverse of this exponential. The inverse now will be like 1 over exponential raised to the power of what? St. Because the minus sign will definitely change to what? Positive sign. So I will continue from this side. I have continue this here. This one I will continue from this point. Then I will now have the f over the t. Then this e raised to the power of minus st will be 1 over e raised to the power of st. Then I have a minus integral of the f over dt multiplied by minus se raised to the power of minus st times what? Dt. Yes. So now you see, I have taken the inverse of this exponential, which is minus st. The inverse now will be 1 over exponential raised to the power of st. So now, looking at this one now, the other part now, the one that has an integral sign, you see that there's a constant here. That constant is minus x. So I will definitely bring it out from the integration sign. Then I'll have the f over the t times 1 over exponential st. Then I have minus, this is minus now. Then this one, this constant is carrying negative sign. So we now have minus x. Then I have my integral sign. So if I remove this minus x, I will have exponential minus st. I will be left with exponential minus st times the f over the t times my dt. So you're going to have the equation in this form. So now I will now have the f over the t times 1 over exponential st. Then minus minus now will convert to positive. Minus minus will give you plus. Plus x integral of exponential raised to power minus xt. Then multiply by the f over the t times what? The t. So now what I'm going to do now is that I'm going to include the limits. So when I include limits, I will include limit here. I'll also include my limit this side. So now my limit now will start from 0 as usual, 0 to infinity. So I will have the f over the t times 1 over exponential raised to the power of st. Then I will put a bracket, then include my limits 0 to infinity. Then I have plus x. Then this integral sign will carry the limits from 0 to what? Infinity. Mind you, these limits 0 to infinity are values of what? T. So you have your exponential raised to the power of minus st, then times the f over what? Dt times what? Dt. So this is how it's going to look like. So our normal evaluation now, it will not be like this now. You have the upper limit, which is infinity, you minus it from the lower limit, which is what? 0. So I'll start with the upper limit, I'll start with the infinity, which is I have the f over the t times 1 over exponential. This is x, this is t, but my t now will be my infinity. I write infinity. So it will now be minus, then minus. I'm going towards the lower limit where t is equal to what? 0. So I will now still write my df. I write my df over the t. Then I have times 1 over exponential. By exponential, then I have x times what? 0. Because my t here is 0. That's at the lower limit. So I have plus x. Then I have my integral sign from 0 to infinity. Then I have exponential raised to the power of minus st. Then I have my df over dt. The f over dt times what? Dt. That's dt. So you have the f over dt times t. Yes, and so now, you know that from this point here, I have 1 over exponential raised to the power of x times infinity, and x times infinity will give you infinity. That means I will have 1 over e. E represents exponential. I have 1 over e raised to the power of infinity, and 1 divided by e raised to the power of infinity will give you what? 0. So you have 0. So here now, 1 over e raised to the power of infinity is 0. So 0 multiplied by this df over dt will automatically give you what? 0. So you have your 0 multiplied by this. So your upper limit now entirely becomes what? 0. So now I will now switch over to my lower limits to get a value for the lower limit. So now I will have, here becomes df over dt times 0, because 1 over e raised to the power of x times infinity will give you 1 over e raised to the power of what? Infinity. And e raised to the power of infinity will give you what? 0. So we give you 0. So that's why that's why you're having 0 here. So that 0 now multiply the f over the t. You understand? So I switched over to the lower limit. I move to this point. I say minus to this lower limit, which is the f bracket df over dt, then times 1 over e. Then this is 1 over e. 1 over e raised to the power of x times 0. And x times 0 will give you what? 0. So you have e 1 over, you now have 1 over e raised to the power of what? 0. And e raised to the power of 0. E raised to the power of 0. You have e raised to the power of 0. This side. Then plus x. X multiplied by the integral sign of 0 to infinity. Then I have my exponential raised to the power of minus st times df over dt times what? dt. So you're going to get it in this form. So of course, 0 times df over dt will give you 0. So say you have 0 minus this one, you have df over dt times 1 over e raised to the power of 0 is what? 1. So you have plus x. They have the integral sign of 0 t to infinity. You have e raised to the power minus st multiplied by the f over the t times what? dt. So now, 1 divided by 1 give you 1. 1 times the f over the t will definitely give you the f over the t. So you have 0 minus the f over the t, then plus x, then have the integral sign of 0 to infinity exponential minus st times the f over the t multiplied by what? The t. So 0 minus the f over the t will give you minus the f over the t plus x, then multiply by the integral sign of 0 to infinity exponential raised to the power minus st times the f over the t times what? The t. So I'm going to get it in this form. So what next? Just know that, but the integral of 0 to infinity of e of exponential raised to the power minus st times df over dt times dt will give you is the same thing as Laplace transformation of df over dt. So this is equal to this. This will give you Laplace transformation of df over dt. So now from our derivation now, I derived first order. I derived the Laplace transform of first order df over dt, and from the value from what I derived, our value got this. This is transform of df over dt. The value will give you from my derivation. I have s f of x minus f of what? 0. So this is the first one I derived. This is the first one I derived. So now I'm going to substitute it here. I'm going to substitute it from this side. So I have my df here. So I'm going to substitute it here. So I'll cancel this. I'll write this equation back. This one, which is minus df over dt plus x multiplied by integral sign of 0 to infinity, the exponential minus raised to the power minus st times df over dt times what? dt. So this equation, I'm bringing it back. So, but this one are just the just for me to let you know that this is equal to this. Then this one now is for my first proof. So I'm going to put it in a box so that you know you can so that you can differentiate so that you know that this one is the continuation of this one. This one is just that I want to let you know that this is equal to this. Then but I know that this from our proof will give you this. So what I'm going to do now, I now have this one is my minus the f over the t. So plus s. So this x now will multiply this one now. This one now is equal to Laplace we give is equal to Laplace transform of the f over the t. So look at it from here, and I'm putting it, I'm cycling it so that so that you understand what I'm doing. But this one now will give you this. So, but that's what I'm saying. This will also you see this the same thing as Laplace transform of the f over the t. So I'll continue this side. Minus I have my minus the f over the t, then plus x multiplied by Laplace transform of the f over the t. And my Laplace transform of the f over the t will give you s f of x minus f of 0. So it will give you now plus s multiplied by s f of s minus f of what? 0. So from here, I will open up this bracket with this f. So I'll open this bracket with this f. I'll have minus df over the t plus s times s will give you x squared of f of s. I have s squared f of s. Then this s times f, this is minus s times f will give you s f of what? 0. So you have the equation now in this form. You understand? So now this the f over the t is first order differential. This is first order equation. That's order 1. So I have order 1 now, which is first order. The order is 1. So if you differentiate the second time, it is called order 2. So now if I have the f over the t, the f over the t will give you f prime. So what if you have d squared f over dt squared, which is second order? It will give you f prime prime. Then if you have third order, which is d cube f over dt cube, it will give you f prime prime prime. You understand? So it's the same thing as your dy. It's the same thing as dy over dx, which is y prime. And then if you differentiate dy over dx the second time, you have d squared y over dx squared, and it will give you y prime prime. You understand? So it's the same thing now is applicable to this to the f over dt, d squared f over dt squared, d cube f over dt cube. So now I'm also going to do it this way. So I have minus f, this is first order, f prime. So this f prime now, where did I get it? This minus the f over the t is the same thing as minus f prime. So I obtained this value from my lower limit here. Looking at this, going back to these steps, where my infinity, which I showed you, my infinity now was 0. So now the lower limit from this side, which is this bracket, then I got minus the f over the t, because 1 over 1 give you 1 times this. So use this minus and open the bracket, you have minus the f over the t. So it was gotten from the lower limit, and at the lower limit, the value of your t is what? 0. So that's why you have f. That's why you're going to have minus f prime of what? 0, because here is at lower limit where the value of your t becomes what? 0. So you have this plus s squared f of s minus s f of what? 0. So now you have finally you rearrange it this way. If you arrange it this way, this one now come first. I have my s squared f of what? X, then minus s f of 0, then minus this f prime of what? 0. So this equation now finally is your Laplace transform of what? Second order, which is Laplace transform of the second order, or the second order equation, which is d squared f over what? dt squared. So it will give you this equation. To give you this equation. So this is the final equation. This is the final equation. Understand? So now this equation now, this one now is the f, this squared f over dt squared. Give you this. What if you are to find the Laplace transform of d squared y over dt squared? It's still the same thing. The only difference here is that wherever you see f, you substitute and put what? Y. So you have x squared y of x minus x y of 0, then minus y prime of 0. So now, if you also have Laplace transform of d squared x over dt squared, you also do this. It's still the same thing. This time around it will be x squared s of x minus x of 0 minus x prime of 0. So it's still the same thing. The only difference is just you change your f and put either y or s. So I'm going to end this derivation here. And please, I would like you to subscribe to my YouTube channel. Don't forget to subscribe, and also you also press the like button in my YouTube channel. As you do so, God bless you.